Welcome to Business Education and Research. In this video, we are going to apply artificial neural network model using SPSS software for predicting stock market price movements. In this model, we are going to use two hidden layers for ANN model. So the data is uploaded on the SPSS software here. The data is about the closing values of Nifty IT shown as bullish as well as bearish. Bullish in the sense, if today's price is more than yesterday's price, the trend is bullish. That is shown as 1. If today's price is less than yesterday's price, that is shown as bearish. That is -1. That is one output variable. That is target variable. This is what we are going to predict. We can name it as dependent variable. The remaining variables are 5 days SMA, simple moving average, MACD, RSI indicator, ADX 14 days indicator, stochastic indicator. Two stochastic indicators are shown here. Stochastic slow K and stochastic slow D. So therefore, there are 6 variables. One is 5 days moving average, MACD 2, RSI 3, ADX 4, stochastic slow K 5, stochastic slow D 6. These 6 variables are independent variables, namely covariates, which are influencing the stock price movements. We have taken Nifty IT as a stock price movements. The index closing value of Nifty IT index is taken as target variable, that is dependent variable. To apply the model and get all complete results for analysis, we are supposed to use the target variables as ordinal scale. The rest of the variables, namely independent variables, covariables, can be any scale. But the target variable, dependent variable, the variable that we are going to predict should be in ordinal scale. Then only we can have all the types of chart that we need for analysis later. So with this brief introduction, let me go for the application of the artificial neural network using SPSS software. On the top, as you are aware, the analyze part is there. I'm clicking analyze in SPSS software and I go to the neural network. Neural network. If you scroll down, you can see neural network. If you select neural network, there are two options. We are going to use Multilayer Perceptron model. So when you click that, this window is appearing. In this window, you have to follow many steps. For example, variables, partitions, architecture, training, output, then save option, export, and other options. So it will guide you step by step. And you need not make any calculations or make any changes. You can accept whatever shown by the system as default. Okay, the starting point is selection of variables. So all the variables that we have uploaded in SPSS software is available in the variable box. So we have to transfer these variables to dependent variables and covariate sections. So what is dependent variable here? Nifty IT bullish. So I select this and click here. So it comes to dependent variable. Then rest of the variables, for example, technical indicators. 6 technical indicators are given as the independent variables, covariates. So I select all 6 variables, just to click under covariates. So it comes here. So this is the first step. The second step in this window is selection of the rescaling covariates. So by default, the machine has selected standardized rescaling covariates. So basically, this step is very important because it is going to normalize the data. In SPSS MLP model, rescaling covariates using standardization ensure that all input variables contribute equally to the learning process. So some variables may have higher value, some variables may have lower values. For example, the target variables is shown as -1 and 1. But whereas rest of the remaining indicators, 6 indicators, have different digits. For example, if variable like MACD ranges between minus 2.5 to 2.5, while 5-day moving average, simple moving average, has values between 10,000 and 12,000. So one variable is shown in two digits. Let us say minus 2.5 to 2.5. Whereas the rest of the variables, particularly simple moving averages, is shown in various ranges, for example, thousands from 10,000 to 12,000. So therefore, the SMA values may dominate the learning process. To avoid that, standardization is done to rescale these variables to a comparable range, ensuring balanced weight adjustments and better neural network training. So in the first window, we have transferred the dependent variable on the dependent variable section, that is target variable. The remaining independent variables, that is covariates, is transferred to covariate section. Then the machine by default selected rescaling covariates, namely standardized, that we have accepted. Just I have explained the meaning of this. So with this, the step 1 is over. Now I go to partition. On the top you can see partition. I click partition. When I click partition, the machine is showing the data in a table, data allocation. So the total amount of data, 1700 plus data, is partitioned by the machine as training data, testing data, holdout data. In the SPSS Multilayer Perceptron model, data is classified into training, testing, and holdout sets to ensure accurate and reliable predictions. So basically, artificial neural network has to be trained like human brains. So it is not going to get the output at one stroke. It makes a lot of adjustments and calculations. So it has to get enough data to get its own training, then only the output will be accurate. So to have training, testing, and holdout, the data is to be classified as such. So training data is used to teach the neural network by adjusting weights based on patterns in the data. So here, by default, the machine is allocating 70% of the data as training data. We can make some changes here. I will make 80%, that is 8 out of 10. So 80% of data will be converted as training data. Testing data is just 1, that is 10%, around 10%. Holdout sample is also 1. I have already explained the meaning of training data. Let us see what is testing data. Testing data helps to evaluate how well the model is learning and preventing overfitting by checking performance on unseen data. Similarly, the third allocation is called holdout data. This is an extra set kept aside for final validation, ensuring the model's accuracy on a completely new data set. So therefore, this classification helps to improve the model's ability to generalize and make accurate stock price predictions. So with this, the second step of building ANN model using SPSS is done. Now we are going to third step called architecture. Just we are clicking architecture. When you click architecture, this window is appearing. So here, the machine is showing a default architecture. We can customize the architecture. So let us click customized. When you click customized architecture, so it has uh, it is showing one number of hidden layer. As already said at the beginning of the video, as part 2, we are going to select 2 hidden layer for this model to get better results. So we select 2 hidden layer. So just I'm selecting 2 hidden layer here, and on the right side number of units is selected by the machine, that is called automatically compute mode. Then activation function, the machine has selected by default hyperbolic tangent activation function, so I accept it. This is for the input variables. Similarly, for output variable, we are supposed to select the activation function. For output variable also, I select hyperbolic tangent activation function. The hyperbolic tangent activation function tan is selected, which is going to reform the inputs into a range between -1 and 1, making it useful for handling both positive and negative values. Normally, if the variable's value is shown as positive and negative values, we are supposed to select the uh, hyperbolic activation function, particularly when the data set is for long period, because in this case the observation is more than 1700 trading days, starting from 2016 to 2024 middle of the year. So therefore the data set is very large and huge. So therefore, to get better and accurate results, we are supposed to go for the hyperbolic activation function. As already said, the number of units in hidden layer automatically it is selected with the machine, but we have selected the double layer. So with this, we finish developing the architecture development. Now let us go for training. Next step in building ANN model is selection of training. So when come to training, let us understand the meaning of the training here. This step in the MLP model defines how the neural network will learn from the data. So it is basically training. The key settings here control the training method, optimization algorithm, and training parameters. So these are all the key measures done by the machine. Let us see one by one. The type of training selected by the machine by default is batch. Batch training is selected, which updates weights after processing the entire data sets suitable for large data sets. So therefore, batch training is suitable for large data set, which is going to update the weights after processing the entire data set. That is the specialty of batch training. Then optimization algorithm. If you come down, you can see optimization algorithm. So by default, the machine has selected scaled conjugate gradient method. This is basically adjust the weights of neurons to minimize the errors in predictions. The selected scaled conjugate gradient efficient for large data sets and speed up training. So for large data sets, to speed up the training process, the machine by default selected the scaled conjugate gradient. We can accept it. The remaining training options are taken by the machines by default. For example, initial lambda value is given as 0.00005. So it controls the size of weights updates. A smaller value results in finer adjustments. That is why very smaller value is taken by the machine by default. Similarly, the initial sigma value is also shown as 0.0005. It determines the scale of weights initialization after how the network starts the learning process. Then interval offset is given. It defines the range within which inputs are normalized, and interval center is given as 0, which represents the mean value used for normalization. Now we are going to select the output. So when you select output, by default, the machine has shown the output as descriptions, diagrams, model summary, classification results, etc. So as already said at the beginning, when you upload the data in the SPSS for applying ANN model, you are supposed to carefully uh, convert the target variables as, for example, here as ordinal scale. When you convert this target variable as ordinal scale, all the options can be available. For example, since I have converted the uh, target variables as ordinal scale, I can select the remaining options as output. Otherwise, this will be hidden. Since I have selected the nifty bullish or bearish, that is the target variable as ordinal scale, I can select all the outputs here. You can select all the outputs. You can have so many charts and diagrams. Okay, so this is done. Now you can save your data. You can save the predicted variable data here, and similarly the p0 value also can be saved. You can select these options. Then I go to exports. You can export synaptic weights also, right? But you have to browse the file. I selected part to file as, let us say, output 2. I can save here. Then rest of the options, I don't make any changes. Whatever selected by the machine is accepted here. So just as a last step, I click OK. Please remember, you are supposed to complete all the steps one by one after understanding the suitable selection option shown by the machine. After finishing all steps here only, you have to click OK. So as a last step, after coming to the last stage of options, without making any changes here, simply I select OK. When I select OK, all the results are available. For example, the case processing summary, the partition of data is shown here. 80% of data is shown as training, testing 10%, holdout 10%. Similarly, the network information is shown in this table. Then the diagram is showing the model of ANN. Here, as already said, there are two hidden layers. This is the two hidden layer models. Then model summary is shown here, and parameter estimator, the calculations and the weights as well as the significance of the various independent variables on the target variables is shown in values here. The classification of results basically tells you the accuracy of the prediction model. Similarly, the predicted P0 value is also showing the accuracy, and Nifty IT bullish and bearish is shown as sensitivity and specificity. Area under curve shows the reliability of the model. So the gain and percentage chart as well as lift and percentage chart shows the effectiveness of the model. Similarly, the importance of the selected independent variables in predicting the target variables is shown as a chart in the form of normalized importance values. So these results we can explain in detailed manner in next video. So this is how you are using SPSS ANN model to make predictions for stock markets. You can make this prediction for other data sets also, not necessarily to stock market operations. You can insert any data for applying the ANN model to predict the outcome. Thank you for watching this video. With this, we close this video. Welcome to Business Education and Research. In this video, we are going to apply the artificial neural network model, Multilayer Perceptron model using SPSS software. This is SPSS software wherein I have uploaded the Nifty IT index for 1781 days starting from January 15, 2016 to 2023. So totally 1781 data relating to Nifty IT index, and the technical indicators of Nifty 50 IT is also calculated and uploaded here. For example, the first column is date. The second column is the Nifty IT value expressed as 1 and -1. So 1 is when the closing price of today is bullish when compared to yesterday. Meaning, if current price is more than yesterday's price, I converted this as 1. If current price is less than yesterday's price, I converted as -1, that is bearish. Bullish means if current price is more than yesterday price, that is bullish, 1. Bearish means if current price is less than yesterday price, it is -1, that is bearish. The next one is the simple moving average of Nifty IT. 5-day simple moving average is calculated based on the closing price of Nifty IT. The next indicator is MACD, moving average, convergence and divergence. is calculated by using the formula. The next indicator applied here is relative strength index indicator, then ADX, average directional index, then stochastic slow K and stochastic slow D. These are all very prominent technical indicators widely used by market analysts, researchers, and participants to predict the stock price movements. So, the technical indicators, namely 5-day SMA, MACD, RSI, ADX, stochastic K, and D. So, these variables are taken as independent variables, and Nifty IT closing value, whether it is indicated as bullish or bearish, is taken as dependent variable. So therefore, the technical indicators selected here, 1, 2, 3, 4, 5, 6 indicators, what is the impact, influence of these technical indicators on the closing value is going to be the analysis here. So totally 1781 trading days are taken here. So it is a very long data. So artificial neural network only can take these kind of large database for applying prediction model, particularly artificial neural network MLP model. So let us go ahead. Before going for applying the ANN model using SPSS, in SPSS window, I go to variable view. I have to convert the target variable, that is the dependent variable, into ordinal scale. So the target variable, dependent variable, the variable that we are going to predict, that is Nifty IT, whether it is going to be bullish closing or bearish closing, is the target variable. So we are converting that variable into ordinal scale. Other variables can be normal scale. That is very important step to be done before going for the application of ANN model using SPSS software. So the first step is go to analyze on the top. On the top of the options available in SPSS software, I select analyze. When I select analyze, carefully I go through each and every option available. I come down to neural network. Neural network. When I select neural network, there are two options. The first option I will select multi-layer perceptron model. When I select the first option, multi-layer perceptron model, this window is appearing. In this window, I am selecting the target variable, that is dependent variable, that is the variable that we are going to predict, Nifty IT, whether it is going to be bullish or bearish. I select that and put it in dependent variable box. Then remaining variables, for example, the first technical indicators is 5 days SMA, simple moving average. I can take it to the covariates, that is independent variable. The next independent variable is MACD, moving average, convergence and divergence. That is also taken to covariates. Then next variable is relative strength index, that is RSI, is also taken to covariates box. Then ADX is taken to covariates box. Stochastic slow K and stochastic slow D. So let us remember, we have taken the dependent variables to dependent variable box. The remaining independent variables we are transferring to covariates play box. This is the very important first step. The next step is rescaling of covariates, that is given below the covariates box. Rescaling of covariates. We will select. But before that, let us have an understanding about the ANN MLP model. The artificial neural network ANN, Multilayer Perceptron MLP model in SPSS is a powerful machine learning technique used for predicting complex patterns in data. MLP neural network consists of input, hidden, and output layers where each neuron processes information using weighted connections and activation functions. Using SPSS, researchers can efficiently train and test ANN models while analyzing key metrics like classification accuracy and variable importance. This video will guide you through the step-by-step process of implementing the SPSS MLP model, covering data preparation, network architecture, training, and performance evaluation. So now, as already said, the second important step in the variable section is selection of rescaling of covariates. So the machine by default selected standardized option. So in the SPSS MLP model, rescaling covariates using standardization ensure that all input variables contribute equally to the learning process. Because when you see there are six independent variables, of the six independent variable, some values are running in single digits, plus one, minus one, and some variables are running in multiple digits. So therefore, we have to go for rescaling of covariates. Standardization transforms each covariates to have a mean value of 0 and a standard deviation of 1, preventing variables with large numerical values from dominating those with smaller values. This process enhances model stability, improves convergence speed, and ensures that each input variable contributes proportionally to the model. For example, if variable like MACD, for example, MACD is here, this variable, it normally ranges between minus 2.5 to 2.5 values. Whereas the 5-day moving average, for example, this variable has values between 10,000 to 12,000. The SMA values may dominate the learning process. Standardization rescales these variables to a comparable range, ensuring balanced weight adjustments and better neural network training. So therefore, rescaling of covariables is very important. Okay, this is the important first step. Then after selection of this, on the top I go to next option called partition. I click just partition. So when you click partition, this table appears. The data set is partitioned by the SPSS software ANN model by default. For example, it classifies the data set into training, testing, and holdout. For example, as already said, we have taken 1781 trading days variables, right? Both the target variables as well as the independent variables. We have taken 1781 sample data. Of these 1781 sample data, we have to classify this data set into three categories, namely training, testing, and holdout. By default, the machine has classified as 70%, 30%, and holdout sample is 0%. Okay. Before making some changes here, let us try to understand the meaning and importance of partition of data set. In the SPSS MLP model, data is classified into training, testing, and holdout sets to ensure accurate and reliable predictions. Training data. This is used to teach the neural network by adjusting weights based on patterns in the data. The first one, training. Next one is testing data. The testing data helps evaluate how well the model is learning and prevents overfitting by checking performance on unseen data. Third one is holdout. Holdout data is an extra set kept aside for final validation, ensuring the model's accuracy on completely new data set. This classification helps to improve the model's ability to generalize and make accurate stock price predictions. As already said, the machine has classified the data set into two categories, namely training 70% and testing 30%. Holdout is 0, but we are going to make some modifications. So I will make training set as 80%, 8. Then testing set as 1. And holdout sample data also 1. So therefore out of 10, let us say 100%, 80% we have allocated for training, 10% for testing, 10% for holding. So normally to get accurate results in ANN model, artificial neural network model, more training data should be given. The machine should be given more database for training so that the learning process improves and machine is able to predict accurately. Okay, that is why we have allotted 80% for training. For testing, only 10% and holdout sample is 10%. So this is the next important step that we have to select. When compared to other ANN prediction model, the ANN prediction model available in SPSS software is highly scientific and very user friendly and can bring accurate results also. So therefore, every option is given and we don't make any calculation. Simply by understanding the steps, we allot the data. We make slight changes, that's all. We don't do any calculations, we don't break our head. So it is the software is inbuilt and simply it guide us. So only thing is we have to understand the various steps and do accordingly. Okay. So the second step partition is done. Then I click architecture. This is the next important step in applying ANN model using SPSS software. So when you see the MLP architecture, so there are options. Automatic architecture selection is given as minimum 1. Okay. Now we can customize this. Instead of going for the default system, we can go for customized architecture. When come to customized architecture, in this video, I'm going to select one hidden layer option only. Maybe in next video, part 2, I will select the 2 hidden layer. But in this part 1 model, I'm going to select only one hidden layer. So that is the option we selected here. Then next, on the right side, number of units. The machine has automatically selected number of units, that is number of neurons automatically by the machine. So let us leave it to that machine program. Then when come to the activation function, there are two options available. For input variables, this is the hyperbolic tangent activation function and sigmoid activation function. I am going to select the hyperbolic tangent activation function for this part 1 video. Similarly, we have to identify the activation function for the output layer also. So therefore, here also I am selecting hyperbolic tangent activation function for part 1 video. Okay, that's all we can do in this section. So architecture is finalized. But before that, let us understand the number of hidden layers as well as hyperbolic tangent. Whatever we have selected, let us try to understand. The number of hidden layers, for example, I selected as 1. This is number of hidden layer, I selected 1. We have selected one hidden layer, allowing the model to learn more complex patterns in the data. Okay. Then second, hyperbolic activation function, we have selected hyperbolic tangent activation function for both layers, this input layer as well as output layer. What is the meaning of hyperbolic tangent function? Hyperbolic tangent function tan is selected which transform inputs into range between -1 and +1. So the data set will be converted by the machine into -1 and 1, making it useful for handling both positive and negative values. An activation function basically determines how the weighted sums of inputs is transformed before passing it to the next layer in the neural network. It helps to introduce non-linearity, enabling the model to learn complex patterns. The next one is the number of hidden layers. Okay, that as already said, we have selected one here. Automatically compute is selection. This is one. Automatically compute selection is done by the machine, allowing SPSS to decide the optimal number of neurons in each hidden layer. So the number of neurons will be decided by the machine itself automatically. Okay, similarly, as already said, I have selected the hyperbolic tangent activation function for the input layer as well as for output layer. So the hyperbolic tangent function is selected because the data set is large and many values are shown in minus as well as plus. So therefore, we have selected hyperbolic tangent activation function. So basically, the main role of activation function is to determine the signal strength. Each and every variable has its own impact weight. Okay, so whether the particular variable on a particular day is able to generate meaningful signal is the question. So the machine will decide whether the signal generated by each and every variable, independent variable, is having a meaningful impact. So therefore, that will be decided by the activation function. If the signal generated by a particular variable is very weak, it will ignore. If the signal generated by the particular variable is powerful, that will be considered as a no. Okay, that will have an impact. So therefore, to decide whether the impact of the particular variable on specific day is having meaningful effect or not will be decided by hyperbolic tangent function. So powerful signal will be considered and weak signals will be ignored by the machine. Now let us go for the next option, training. So when we come to training, the various informations are given in the uh, menu. This step, basically training step, is the MLP model which defines the neural network that learn from the data. So training is basically facilitate the neural network to get training so that it is able to predict well with more accuracy level. The key settings here, the control training method, optimization algorithm, and training parameters. These are all various important options here. So the machine selected the batch option automatically. Batch training, for example, is batch training. This batch training is selected which updates waits after processing the entire data sets suitable for large data sets. So batch training is basically suitable for large data sets. Then optimization algorithm. This is the next level. The machine has selected scaled conjugate gradient method for optimization algorithm. Okay. Optimization algorithm adjusts the weights of neurons to minimize the error of predictions. The selected scaled conjugate gradient is efficient for large data sets and speed up the training process. So the weights is to be assigned by the machine by random. It will make some calculations. So for assigned weights, each and every variable will be assigned some weightage. Okay. Then at the end, it will make calculations and see the result. When the results are accurate, the weight will be adjusted, will be accepted. If the results are not handy, if deviations are very high, then it will go for backpropagation model and reassign the weight. So therefore, how the weights are given and how the weights are changed, adjusted is decided by the scaled conjugate gradient method of optimization algorithm. Now training options are given at the below. A box is given, training options. So initial lambda value is given. That is 0.00005. Okay, it controls steps of size of weight updates. A smaller value results is finer adjustments. Then initial sigma is given as 0.0005. So this determines, I mean, initial sigma determines the scale of weight initialization affecting how the network starts learning. In our last but one is interval center, that is 0, represents the mean value used for normalization. Then interval offset is given as plus or minus 0.5, which defines the range with which the inputs are normalized. So these are all the training options available. So the options we have to select. For example, I have selected batch training here. And when come to optimization algorithm, we have selected scaled conjugate gradient method and training options. By default, the machine has selected initial lambda value, initial sigma value, interval center, and internal offset. If you want to make changes, you can make changes and see the results. So when results are perfect, you can accept. And with this, I go to next step called output. Basically, the output window shows what are the results that you need. I will select all options here. I will select all options here. Then it asks you, how do you save? You can save the predicted value and save predicted residual probability for each dependent variables. You can select. Then export options. You can export the results. Then options, last option. Uh, we don't see anything here. Okay, then that's all. just we click OK. Now we have to select the location. So I'm selecting the location, for example, workshop. I can select. We can select the file name. Let us say I can say testing 2 as file name. I can save this. So you are supposed to export. If you want to export the file, you are supposed to export and select the location folder and give the name for the file. Last one is option. Here, I don't make any changes here. Whatever suggested by machine is accepted here because the understanding is that the machine will give you the better options. So last step is click OK. That's all. Now the results. You have the results. So multi-layer perceptron results are available. First, case processing summary. So what is the total database? 1781 is the total sample size. And this is classified into three categories, namely 80% training data, testing 9.6, that is almost 10%, and holdout 10%. Of course, we selected 80, 10, 10. The machine is making its own calculations in order to generate better results. It allocates as 80.2%, 9.6%, 10.2%. If you total, you get 100%. The next table is network informations, the details of the covariates, independent variables, number of layers, all the details, rescaling methods, and activation function, everything is given here. The output variable is also given here. Now, this is the neural network model generated by the ANN MLP model of SPSS. So the first layer is called input layer, wherein we have all 6 independent variables and one bias value is also given. The error function is also calculated by the machine that will come in every layer. So the first layer is called input layer. The second layer is called the hidden layer, single hidden layer. As already said at the beginning, we have selected single hidden layer model. So therefore, here you have only one hidden layer. If you go for two hidden layer, one more layer will appear here. So there are 6 variables. The 6 variables are able to generate how many neurons? 1, 2, 3, 4 neurons. So it filtered 6 variables into 4 categories, okay, based on the activation function. Activation function basically assigns weight for each and every variables and make calculations. If the variables are able to generate powerful signals, that signal goes to this layer. If the signal generated by the particular variable for specific day is weaker, that will be ignored by the machine by following the activation function. We have adopted hyperbolic tangent activation function. Okay, so this is the hidden layer, and this hidden layer is generating the final output layer. So the final layer consists of two. First one is the Nifty IT bullish index 1, then bearish is -1. So therefore, the model is able to predict the outcome under two classification, whether today's closing price is going to be bullish or bearish. Bullish means today's closing price will be more than yesterday's closing price. Bearish means today's closing price will be less than when compared to yesterday's closing price. This is the model shown as a chart, as a figure. Then model summary is also given here, and parameter estimated is given here, and classification of prediction is also given here, and the predicted pseudo probability is also given as a form of chart. Then the sensitivity and specificity is also given here. Area under curve is given as a table. Normally nearing 1 is the excellent results. More than 0.7 is okay, but here the results are 0.983 for both -1 as well as +1. So the results are perfect. Robust results are we are getting. Then there is one more chart called gain and percentage chart. Then percentage and lift chart is also generated by the machine. The importance of variable. So we have input 6 independent variables to predict the final outcome. Out of 6 input variables, which is important, which is very important, is shown by this classification. that is called independent variable importance. Normalized importance value is given in terms of percentage. The same value is represented in the form of chart. In the next video, I will explain how to understand the results. Interpretation of the results will be a separate video because that takes a lot of time to explain each and every point specifically. So in this video, we have explained the database, then we have uploaded the data in SPSS software. We selected the option of multi-layer perceptron model, and one by one, step by step, we have selected the various steps that are to be done for generating the results, and finally we got the output. The output is shown here. So the interpretation of the output, explanation of the output will be another video. Thank you for your time for watching this video. Thank you.